Hey there, and welcome to Null0 Labs. Guess what? We may have bid farewell to Bob, but don't worry, I've replaced him with Sniff, our new packet hound. And that clever little hound is on a mission to sniff out misconfigs and rogue broadcasts. This week, we're building a new data center. So we've opted for spine and leaf architecture because it's fantastic for prioritizing redundancy, scalability, and low latency. So if you're into building networks, stay tuned, like and subscribe, and let's dive into the lab. Sniff, bring me that Nexus. Hi, and now we're back in the lab. Today, we're going to start by configuring our data center spine and leaf topology for our first tenant. So we're going to start as a single tenant topology, which is the green boxes. And then we're going to progress into a multi-tenant topology where we're going to add a second tenant, which is the purple or pink boxes. We're then in another video going to add an external gateway as a shared resource supply internet access both the tenants. Now you can imagine that each one of these leaf switches is sitting in a rack or cabinet within our data center, connected back to our spine switches, which are obviously connected to other leaf switches in other cabinets in other parts of the data center. Now, what we're configuring here is again yet another encapsulation method where we're going to take the layer 2 switching frames that are happening down here. We're going to encapsulate them up into VXLAN, ship them across a layer 3 network, and spit them back out at the other end at the VTEP or a virtual tunnel endpoint, again, the switch, and we're going to decapsulate it back into layer 2 frames. So we're going to start by configuring our underlay. So we're going to start on switch 1, spine 1, I should say. And we're going to start by enabling about 7 different features here. So we need, and I'm not going to be able to remember them all, so I do have a list. So we need to enable OSPF because we're going to use OSPF as our underlay. We do need BGP because again, that's going to handle some of the overlay stuff for the PIM. That's for our rendezvous point, etc. for our multicast traffic. Feature fabric forwarding, we need that. We definitely need a interface VLAN, a VLAN interface, and then we're going to need some VN segment based VLANs and feature NV overlay. Right, so that's a lot of features. So if we have a check here, so these are the features we've enabled. 1, 2, 3, 4, 5, 6, 7. Yep, 7 features. I was correct. So we need those. What I will do is we will enable those on our other switches because they are all going to need that. Saves me having to type that long list back in. Jump on to the other steps. Okay, so all of our switches have now got the feature set that we require. Next, obviously each device is going to have what we're going to do is for the point-to-point links between the spines and the leaves, instead of numbering all of these, going /31 or a /30 IP address for every single link, because that could get quite tedious when we've got a lot of them. We're going to IP unnumber each one of these links to the loopback. So each device is going to have its loopback address. So we're going to use 10.0.0.0/24, and that's going to be our loopback range, and we're going to assign a single address out of that range to each one of these devices. So first of all, let's do the underlay. So we're going to go router OSPF underlay. Now we're going to go int loopback 0. This will be the spine 1 loopback. Okay. And then we will set an IP address of 10.0.0.1. Okay, that gives that an IP address, and then we will put it into our OSPF area. So that's IP router OSPF area underlay area 0. Okay. So what have we done there? We've started the OSPF routing process, and we've set up our loopback 0, and we're now saying we're advertising the loopback into OSPF area 0. So that's that. So now we're going to configure these 3 point-to-point interfaces that are going towards each of the leaves. So we'll configure those next. Then we'll do the same for spine 2 and the same for the leaves. And then we'll check that we have our OSPF neighbor relationships and our interfaces up between each of the devices. On spine 1, we can go int e1/1-3 because we're going to use all 3 of them similar. So we'll say these are 2 leaves. And we'll do a no switch port because these are going to be routed interfaces. We are going to set an MTU, or we're going to set a jumbo MTU, I should say. And then we're going to do the medium. What we're saying here is that this is going to be a point-to-point medium, not a broadcast medium, because we want to unnumber it to the loopback. So now that we've set that, I can do IP unnumbered to L0. That gives each one of these interfaces an address, but the IP address is the loopback address. Next, we're going to set up the OSPF. So we'll do OSPF. We'll set the network type again as point-to-point. And then finally, we will advertise it into IP router OSPF underlay area 0 and no shut. So there we can see we've got our 3 to the leaves connected. They are configured as rooted. Show IP int brief. There we go. We can see the loopback address, and each one of those physical addresses, physical interfaces, I should say, is unnumbered back to the loopback. So let's go and jump on to spine 2 and do the exact same. So now that the feature set has been enabled, we are going to set up our OSPF underlay. We're going to set up our loopback. And we are going to give it an IP address, 10.0.0.2. And IP router OSPF underlay area 0. That's good measure. So that's our loopback address. Next, we're going to configure, again, the spine has 1, 2, 3 connections down to each leaf. So we're going to configure those. To the leaves, the medium going to be point to point. This will allow us to do an IP unnumbered to L0. We will set the MTU of 9216 jumbo, and we'll do a no switch that first, no switch port, just to be sure. And then finally, we'll do OSPF network type will be point to point, and IP router OSPF underlay be in area 0. So shut those, be sure. Now, if we double check here, show int status, you see we've got our 3 point-to-point connections to our leafs. We can see we've got our loopback address up, and we can see we've got our physical point-to-point links unnumbered to the loopback. Okay, so now we're going to do the same for our leaf switches in our racks. These only have a link to each spine. So again, we're going to give it a loopback, and we're going to assign the physical links back to the spines, and we're going to set up the OSPF routing underlay. Then we should be able to then check that we have a neighbor relationship between all of our devices. We should be able to ping all of our loopback addresses. Every device should be able to find every device. We should then be ready to then move on to our next configuration step. Let's do the third one. A lot of repetition here, but at least like it will go in and stay in. So again, we're going to set up the router, OSPF underlay, log the adjacency changes, and now we will set up the loopback. Again, description, this will be a leaf freeze loopback. It will have an IP address of 10.0.0. There will be 1, 2, 3, 4. This will be 5. And we will put it into the OSPF. Do its 2 interfaces towards the spine. So E1/1, 2, description, 2 spines. The no switch port command. So it's a rooted interface. Remember, we're not doing layer 2 up here. The medium be point to point. IP unnumbered to L0. MTU B9216. IP OSPF network type will be point to point, and IP router OSPF underlay area 0. So shut. So in status, here we have our 2 links to the spines. They're connected in rooted mode and they are online. We can see our loopback address is correctly configured and the 2 interfaces are unnumbered to the loopback. We can see that leaf 3 can see spine 1, 2, and leaf 1 and leaf 2, all via the underlay OSPF configuration. So that's all looking good. So let's save the configuration we have so far. Now let's verify from spine 1 that it can see, it has a full picture of the topology. So spine 1 can see spine 2 via leaf 1, 2, and 3, because spine 1 is the spines are not directly connected. And then we can see leaf 1, leaf 2, and leaf 3. So spine 1 knows about spine 2 via the connections of leaf 1, 2, and 3, and spine 1 can see leaf 1, 2, and 3's IP addresses all correctly there. Let's just verify on spine 2. Again, it can see spine 1 and it can see the 3 leaf switches. So that is looking good. The next, we are going to set up the multicast configuration PIM on the spines and on the leaves. And then finally, we will set up our NVE. I always want to call it an NVI interface, but an NVE interface on the leaves, because that's where we're going to be doing the translation of layer 2 into layer 3. So we'll stick that down there, and then that will be our underlay complete, and we can move on to our overlay. So let's get the spines configured first. So we will start on spine 1, and we're going to set up a multicast address and an anycast multicast address. We're going to set up another loopback interface, and then we're going to do the same for the leaf switches. And then we'll be able to test that and make sure it's all operational. So on spine 1, config T, we're going to IP PIM, the rendezvous address is going to be, and we're going to use the top one out of our loopback pool, 254. Group list of 254.0.0/4 according to the documentation, and IP PIM SSM range of 232.0.0.0/8. And now we say IP PIM anycast our router is going to be 10.0.0.254, and we are going to host it, and the second spine is going to host it. And then int L1, secondary one, and we'll call this the PIM RP loop back, and then we'll set an IP address 10.0.0.24. And we will advertise that IP OSPF, no, IP router F underlay 0 IP PIM fast mode. Int L0, add that. Int E1/1 to E3, enable it on there as well. Now we're going to go and do the same on spine 2. IP PIM rendezvous point address interfaces towards the switches. Then we're going to go and do the same down on the leaves, but it's slightly different. So we're going to do the IP PIM rendezvous address we know is 10.0.0.54. Group list is 224.0.0.4. Range going to be 232.0.0.0.8 default anyway. And then again, we will not do a rendezvous point router because the spines are handling that. The spines are acting as the multicast traffic routing gateways, and I've got 2 of them, so we set both of them up so they're redundant, etc. Int L1, nope, doing a 1 on the spine, so no int 1. Int L0 IP fast mode, and then we will do the same for int 1/1 E2. Okay, that should be it there. And now what we would do is we'll copy and paste this onto leaf 2, onto leaf 3. Same. And And once we've done that, we will then just jump into our interfaces. So in L0, the class mode 1/1 to E2. Same. 3, 0. IP class mode 1/1 to. So save that. And now, if we verify and validate, we should be able to go on the spines, go show IP PIM RP. Okay. You can see the rendezvous point address is there. That's all correct. Where is members? There we go. Our members. As we can see, 1 and 2. We can see there. We can see this one hosting it. Perfect. Right. So that is operational on both of the spines. Perfect. Right. Now let's configure the config on the leaves to get the NVE interface online, and we can then move the overlay. So on each of the leaves, we're going to do int NVE1, no shutdown, and host reachability is going to be via a BGP. And the source interface is going to be L0. So int NVE1. There we go. Encapsulation of this. Everything's going to be done via this interface. Once we've turned it on, you'll see that we have to apply, we have to put all of the VN segments, all of the layer 3 LVNIs, they go on here as well. So int NVE1. No shut. Host reachability protocol will be BGP, and the source loopback 0. We only do it on the leaves because the leaves are the ones that are doing the encapsulation. Double check that we've saved everything. Always double check that in case you have to reboot something and then you find, all my config is gone. We've now basically configured the underlay. So all we've achieved now is that every single leaf, see each of the spines, spines can see each of the leaves, spines can see, the spines are running our multicast router rendezvous point addresses for each of the devices. We've set up our NVE interfaces on each of our top of rack leaf switches. So we're now ready to set up our overlay configuration, which will. Okay, so let's start with our BGP overlay on spine 1. So I'm going to jump into the config mode. We're going to do NV overlay EVPN. We're going to create some EVPNs for layer 2. So let's start with the spine configuration, and then we will verify that each of the leaves can see each of the spines via BGP, and the spine 1 and spine 2 is going to act as the route reflectors for each of the leaf switches. So router is going to be BGP 64500. We will use as our ASN. Log adjacency changes. The address family is going to be IPv4 unicast. Address family IPL2 VPN. Going to be EVPN. Main root target all. Up a template for our leaves. So the peer will be leaf. So the remote AS is going to be the same, 64500. Update source, the loopback, family, IPv4 cast, and we send community extended. They will be a root reflector client. Family will be L2 VPN, eVPN, and community extended, and a root reflector client. Okay. So 3, 4, 5. That's what I remember. We will inherit here, leaf. Do that for our other. Quick check. Okay, so we've got configuration, act as our root reflector. We've got our here template, and we've added our 3 leaf switches, and they are up here. So we can copy this and put this straight onto spine 2 because it's going to be identical. It not like there. Why didn't you add the okay. BGP 64500. What have we got a problem with here? Not showing that. We not in we didn't do on here. We didn't NV overlay eVPN. Now that there we go. We now have BGP configured for the spines. Now let's do the BGP configuration for the leaf. It's going to be similar. BGP 64500 again. Actually, no, we better make sure we remember that we need to enable the fact that we're doing multi-protocol BGP. So we need to do the NV overlay eVPN. So I'm going to do that on both of those before I forget. Okay, and now we can do a router BGP 64500. Changes the family IP4, make sure there, yes. One was L2 VPN, eVPN, yeah, that is there. Cool. All right, so template, and it's going to be appear is fine. Remote AS is 64500. Update source, the loopback 0. IP4 unicast, send community extended. Configuration on inbound. Family L2 VPN, EVPN, we send extended neighbor 10.0.0.1 will inherit spine. That should be it. That one. Do the same for the second spine. That should be it. So now we can copy this onto our other leaves. BGP overlay configuration. That is all looking good. We'll copy that. Ones is all the same. Cool. Okay, right. So on spine 1, we'll show BGP, IPv4 class summary. Yep, we can do 3, 4, and 5. So BGP 4 unit summary. 3, 4, and 5. Good. So all of those are seeing each other. Do the same for the L2 VPN. EVPN. Yes, we have a neighbor relationship with that. Yes, we see the other 3 again. So we are done with our overlay and underlay. So we now have our base configuration in. All right, let me close off spine 1 and spine 2 because I just misconfigured and configured the L2 VNI on the spines, which I don't want to do. We want to do that on the leaves. So we are on leaf 1, and now we're going to create our VNIs. So we're going to start with VLAN 10. We're going to give it a VN segment number of 10.0.0.10. And then we're going to go to the interface NVMe NVE1. We will enable this double width ARP PCAM in a minute to our NVMe interface. So we're going to add VNI 10.0.0.10. Basically, we're adding that VLAN. Press the ARP. Give it a multicast group 224.1.1.10. Do the same VLAN 11. Give that a segment number. Jump back on here. We will make 7 a member. We will press the ARP. Get a multicast group. The VPN. We will do VNI 10.0.0.10 layer 2. Auto port target import. What would be auto? Do the same for the other VLAN. That's on leaf 1. Add that TCAM configuration to each one of the other switches because we will have to do it. Just a matter of taking away some resources with one hand and giving it to another. Now we're going to add the VLANs onto the same VLANs onto the other two leaves. We're going to need VLAN 10 and 11. Add those. 10 and 11. Add them to the NVMe interface. Add them down here. And then we need under the NVE interface here. Those two members of one of these. Yes. VE1. Leave that. I think we can see our VNIs are up. So one of those should see each other. Okay, so now that we've configured and our VNI interface is up and we've configured the VLANs 10 and 11, technically that's all layer 2. So now if we configure the interfaces towards these devices on each of the switches and put them in the correct access VLAN, technically the layer 2 stuff should now work. So let's give that a try. So if we look at that, so that's int 3 and int 4 on leaf 1. So int 3 description v10 server 01 switch port access switch port, so switch port mode access port access VLAN will be 10. No, shut that. Then int e1/4 be the same. It'll be a switch port mode access. It will be in VLAN 11. No, shut. Description will be VLAN 11. What did I say? VLAN v11 hyphen server 01. Now if we jump onto leaf 2, look at leaf 2 here. It's got the same 3 for VLAN 10. That's so int e1/3 description v10 hyphen server 2. The switch port mode is going to be switch port mode access or access be a VLAN 10. Int 1/3 description is going to be v11-server 02. Switch port mode access port access will be VLAN 11. Shut. Onto server 1 ping 10.10.10 10.10 1.1 is its local address. One in rack 2 10.10.1.2. There we go. We're now taking layer 2 to layer 3, coming back over here, coming out again as layer 2. So if we jump onto leaf 3, we should be able to configure its interfaces 3 and 4 again for its VLAN. So it's 3, copy and paste this, show run 1/3. The description be attend -server 3. /4 v11 server 3. Now from server 10 in VLAN 10, it can ping 10.1.1.1.2. Should now be able to ping 10.1.1.1.3. Yes, it can. Same for 11. Going to ping 10.11.1.1 itself. We're going to reach 2, which it can. Be able to reach 3. Now let's add this into, let's set up the layer 3 VNI, the gateways, so that the two VLANs can intercommunicate with each other, and let's move them into a tenant. Right, now that we know that we've got functionality between our racks, let's set up our layer 3 VNI and our Anycast gateways for each of these top of rack switches, and then we'll then move this setup into its proper tenant enclosure. So let's start with leaf 1, fabric forwarding MAC address. Got our VRF for our tenant 1. Put VLAN, an interface for VLAN 10 and interface for VLAN 11 as VRF members of tenant 1. Got our layer 2 VNIs, and we've got our layer 3 VNI. So that's correct. We now need to give our interfaces, our layer VLAN 10 and 11 will give them now a IP address and put them as part of the forwarding fabric. So we jump onto the in VLAN 10. This gets a lot simpler once we get this one done. We can then copy it across. So in VLAN 10, the IP address will be 10.10.1.254. And it'll be a fabric forwarding mode, be Anycast gateway. In 11, IP address is 10.11.1.254/4. Again, that fabric Anycast gateway address. So if we look, we've got our Anycast MAC address. We've got our layer 3 VNI and VLAN set up for tenant 1. We've given our layer 3 addresses for VLAN 10 and VLAN 10 and 11. They are members of that VRF context tenant 1. So now they're basically technically all grouped together. So if I do like a show IP route VRF tenant 1, we can see that it's got nothing at the moment, but everything should be under that one tenant. 10.10.1, 10.10.1.254. Why isn't 2 VLAN 11 showing there? No shutdown. Yeah. There we go. The VLAN 10 and VLAN 11 layer 3 are all carved off into their own VRF, their own virtual context. So they're all segregated away. The next thing we need to do is we need to add that onto the VNI interface in NVI 1 and to member 90396 associate VNI 396 that. So that should give us that. Now if we stick that into our BGP, so if we go router BGP 64500, we go VRF tenant 1, log the adjacent address family, IPv4 unicast, and we're going to advertise networks 10.10.1.0/4, 10.11.4. So we verify got everything in place. Should now be able to ping switch 10 to 11. So if I go 11.1.1, there we go. We now have inter VLAN routing on leaf 1. Root VRF tenant 1. So yeah, tenant 1, that subnet's gateway, you can see that you can see the 11 subnet, obviously you can see the 10 subnet. That's functional. Show VE1 VNI. Probably not doing a very good job of explaining this. So we have our layer 3 VRF context that we use to sort of bind up all of our layer 2 networks behind, and then that is all grouped together. So we've got our separate layer 2s, we've got our layer 3, and then we bond everything that is going to be crossing over, takes the path via this layer 3 VNI. So all the layer 2s, if they want to intercommunicate, they use this layer 3 VRF context to keep them all segregated from the other tenants, and it also is what's used to transport it across to the other leafs. So we're now going to copy pretty much the same setup over onto our other leafs. So we'll give every leaf Anycast MAC address, which will be the same for this fabric. Each one of those has got the same, because like at the moment, if I go to 10, shouldn't be able to ping, say the one in cab 3, which is 10.11.1.3. Yeah, see, I can't get from here to here at the moment, but once we put the configuration in place for the routing, we will be able to. Layer 2 is all up and running, but layer 3 isn't. Let's add now a VLAN for that. give it a VNI number. So we need one of those on every switch. That has to be the same. So we've done that. We're then going to create our context. Tenant 1, bond it to that network VNI that we made. Add that on each of our switches. Our VLANs 10 and 11, the configuration of those for those interfaces is going to be identical on all the leaves because we're using an Anycast address. And then we're also going to do the same layer 3 wrap-up interface each of the leaves. So basically this address will be the same on each of the switches because they'll just go to whichever is the closest. We will do the same on here. We will do the same on the third leaf. And then we're going to bond and associate that into our NVI base. I want to call it an NVE and NVE. So in NVE1, bond the layer 3 in there. And then finally, we're going to update the BGP configuration, add the tenant and advertise those networks. Over on leaf 2. That tenant. Router, BGP 100. That. So we should be able to go from cab 1, server 1, VLAN 10 to cab 3, server of 3, VLAN 11. There we go. And just on a side note, after going back and checking show run int NVE1, until we added the tcam command, the suppress ARP statement didn't hold. So now that it's in place and we have a look, we can see that layer 2, layer 3 ARP suppression is turned on for our 2 VLANs, and we can now see that we are now caching IP addresses and MAC addresses and where it needs to go. So obviously it knows that on leaf 1, it knows that the address of 10.10.11 and its MAC address is available via an Ethernet interface E1/3, and it knows to reach 10.10.13, which this server is currently pinging over in cab 3, is available via the VTIP of 10.0.0.5, which is obviously leaf 3, which is at the top of rack 3. So now it's now built a similar table that you would find on a switch for layer 2. So it now knows that if it wants to reach this IP address, it has to go to this remote VTIP, and then obviously this switch will have a layer 2 entry for that MAC address saying it's out of port E1/3. So I hope that helps understand why I wanted to get that enabled. So now we have full communication for tenant 1 between its 2 VLANs, between every single cabinet. All of the leaf switches have a VRF to maintain all of that tenant 1's traffic within its zone. We have our layer 3 VNI configured for tenant 1. We have Anycast routing addresses configured. We're now correctly handling the multicast traffic. So in the next video, we will set up tenant 2 and VLAN 20 and show how VLAN 20's traffic is completely segregated from tenant 1's on the switches. And then we will then add on leaf 3 some leak routing where we will allow the two tenants to be able to see each other. And so that's the plan for the upcoming videos. If we look at briefly switch 10, server 10 again, if I do a trace to 10.10.1.3, we can see that it shows from getting here to here, it's as if it's within the same network, the same as if it's in a VLAN. If we watch it go from 10.1.3, you can see it hits the Anycast addresses and then it hits the server. So that server is 3 hops away. If it does it again to the one that's in rack 2, you'll see again, it's 3 hops away. So every time this server wants to talk to another server with any of the cabinets, at max, it's always 3 hops away. So I hope that helps. I know it's a bit of a long video and probably I probably haven't explained it well, but that is our basic spine and leaf topology with a single tenant setup. So I'll see you on the next video where we'll set up tenant 2.